So in Sweden now that's allowed, and just to be very, very safe, they say it needs to be stored for 6 months. And it's now allowed and is being used. It's directly drilled into cornfields, wheat, rye and barley fields now as the only source of fertilizer used to grow those sorts of crops. So it could go into agriculture. So, and the transport cost, so this is obviously using energy and this is using energy. So when you do a life cycle assessment of all the energy in transporting and storing and processing, so to speak, you can transport it at least about 60 miles as the yellow water before the transportation cost would suggest it makes more sense to turn it into a pelletized fertilizer. So that again gives you some boundaries. So I'm asking the question, we drew a circle, not out to sea perhaps, but on the inland side, what sort of agricultural opportunities might we have for a yellow water fertilizer within the agricultural sector here? What are those opportunities? I think I'll jump over that. So at the household level, we could have simple drainage systems and treatments that go into groundwater infiltration, but that's what we know is part of the problem in this area, that our septic tank absorption trenches are too intimately connected to the groundwater that flows ultimately into the coastal environment. So this sort of scenario is not really on the option list here, but this box, which can treat either whole sewage or just grey water, is just a little series of surfaces that microbes colonize. This is commercially available here in the US as a way of treating either grey water or black water combined. The maintenance requirement is what's been shown here as sort of annual inspections are done by not by the owner, but by the operator of this system. And they can come and spray down and check the cleanliness of these membranes that are used in here, these surfaces. This is an Australian grey water system that does much the same sort of thing. So these are commercially available grey water systems designed for individual houses or clusters of houses. These exist, available. They treat water in Australia, for example, that is then allowed to be used back in the home for toilet flushing, clothes washing and garden irrigation. So these are the sorts of systems that do exist today that could be demonstrated here for those interested. Of course, there are other options that are available. There are toilets that are standalone, that the residuals are basically partly composted and end up in a tray that needs to be pulled out and the residuals put into either, in this case in Sweden where they're used, they're just put in with the municipal organics and can be then municipally composted. There are these sorts of toilets that drop down into a bin that can be urine diversion or not, and so you can collect both streams separately or individually, and again taken off site and composted in a hygienic way. So these are systems that require no water at all. We have urine diversion. This is why urine is worth diverting. So the urine is appropriately yellow here, and so the amount of nitrogen is about 80% is found in the urine stream. In the feces, we've got about 10% of it here, and then a small amount in grey water. Now this is data from Europe, so one of the demonstration points here would be how different, if any, is the grey water quality from the point of view of nitrogen, phosphorus and potassium in this locality. But this is just the general numbers for nitrogen, phosphorus and potassium, whereas the wastewater is largely grey water. Most of what flows in the sewer is grey water. So we're spending all that energy, if you like, producing drinking water, transporting it and then treating it the wastewater works by diluting all those good nutrients and energy organics with this grey water. So that's why I'm suggesting one scenario, sort of suite, consists of separating grey water, treating that more on site so you reduce the energy required in the whole system structure. These are just some other urine diversion toilets that are available commercially, just for those who haven't seen them before. So yes, guys need to stand up and aim straight, or sit down. So the sorts of issues with these are that if a little kid comes along and sits on this, you have to have a baby seat on top here so they don't defecate into that front zone, for example. It needs to go here. If you do defecate into here, or paper goes down there, and blockages have been one of the issues that people have dealt with. So the newer versions of these toilets have a larger, if you like, orifice to reduce that blockage. And the other thing is you need a U-bend somewhere to stop odours coming up from the storage tank. And so the earlier toilets used to have that U-bend at the toilet, and that was another site prone for blockage. The more recent versions of these urine diversion toilets made in Europe and Scandinavia don't have that. They have a wider bore pipe that goes all the way to the storage, by gravity, to the storage tank, which is generally in the basement. And at the basement is where you basically have your water seal, so you don't get odours then coming back up the system. This is my actually house in Sydney, in the little basement I built under my dining room table to fit a urine storage tank. So there's an example of a sort of cubic metre tank. And that's the urine stream coming in from my 2 urine diversion toilets. And the gravity, and this is the gravity sewer, so this is a dual flush toilet that I have. The urine diversion toilet that is commercially available, and so this is the sewer line that comes in. This device enables the water that goes around with a swirl, and what happens here is that the water follows this curvature, whereas the feces and toilet paper and solids drop down into this worm composter. So this is again a commercially available in Sweden device. It's called Aquatron, just as an example of a solid liquid separator with really no moving parts other than what's in the sewer. So it's a pretty neat concept, and it goes into this composter, which has basically just got 4 sections, and manually you need to turn, in this case, every 3 months. You turn it a quarter, then you turn it again another 3 months' time, and the worms in there really break down this stuff, and after a year and a half, you can go in there and you can push back from one sector to another, so there's a little bit of manual involvement here, but you're dealing with what is just worm castings. It looks and smells just like soil. It's brilliant how well worms work on human feces. So when you separate out the urine, which is the odour part, typically in these systems, with just the feces and toilet paper going in there, it's basically an odour-free situation. And that's the urine diversion toilet I have, and that's showing it sitting on the wall. So it's a wall-mounted unit. The urine goes down through this smaller pipe and the feces there, and it's just a standard dual flush toilet. So what else is in the pipeline? So I've given a hint of where toilet technology potentially is going. There are existing things that can be configured and demonstrated today in this community, amongst other communities. Some other inventions that are just becoming commercial. In England, there's the Propel air toilet. So this uses 0.4 of a gallon to flush. So it's not quite a vacuum toilet. It uses a little pump that pumps water and air to flush the toilet. It's a pretty neat idea. So it's a fairly standard looking toilet. It's just got the one flush button, but it does need a little bit of energy to flush, but it's trivial in the whole scheme of things. And it can be retrofitted into a building and go up and down as well. It doesn't rely on gravity, so it can be retrofitted into a plumbing system. As you can see here, how much less energy and water it uses to a conventional toilet system. Grey water is a big user, or I should say showering is a big user that produces a lot of grey water. There's a company in Melbourne that produces this recirculating shower. So if you want to take a long shower and not feel guilty about it, you can buy one of these units off the shelf today. They're expensive, but in essence, once you've washed your body for a few minutes, you can put your big toe on this button and it turns it into a recirculation shower. So the shower water is collected and pumped back up through a heat exchanger to keep it hot, and it comes back out there. And so you can be in the shower all day and use no more water if you want to. Probably dangerous if you've got teenagers. But again, as you can see, it uses a lot less energy because it's not using any more water, it's not heating a lot more water, it's recirculating that hot water through a simple heat exchanger. So these are things available today. Both the Propel Air is commercially available and the Quench is commercially available. And something else that's almost commercially available, it's being tested here in Kansas City, is a clothes washing machine that uses coupled water and detergents to wash your clothes with. And so I won't go into the technology unless you're interested in that. But so this is giving you an idea that we need to be thinking about the demand side as well as the supply side when we're thinking about where we're moving in the future. We don't need as much water because we've got these water-saving options that are also energy-saving options. So we don't need to have big water supply mains and water reservoirs for firefighting supply requirements. We can move beyond that. That's really 200-year-old technology and thinking. We can now move beyond that. but really here to try to bring the suite of tools that we're developing in the Office of Research and Development that enable us to look at the human health side of things, the environmental and the economic, so that the triple bottom line approach, as it's often called, to how we come to look at more sustainable solutions, not just for this community, but what could be replicated from this community across the country, quite frankly, in the various ways that are suitable to those different regions of the country. So I will say thank you and open it for questions.
Hi, I'm Lee from reporting for the Barnstable Patriot. I just wondered if the EPA was offering any incentives for this kind of change.
As I tried to say at the outset, I'm in the Office of Research and Development, so we're really trying to underpin the direction and give advice to, in this case, the Office of Water, who have the main regulatory role here. But the quick answer is yes, we need to be moving into, rather than largely focusing on rules and regulations and compliance, what we're doing in the Office of Research and Development is looking towards what are the more sustainable options here, and therefore what are the incentives that might get the country to move in those directions. And I would hope EPA, in collaboration with a range of agencies, in fact, because we need to be dealing with energy agencies as well as the water type agency or environmental agencies and others, and CDC and others. So we need to be working across the agencies, but you're right, giving incentives to encourage this good behaviour, if I can call it that, or this change in the approach. So yes, in principle, I would expect EPA to be moving more in that direction. We currently give guidance that way. Whether we're going to give economic incentives or whether, other things, that's a policy call which is well outside my area. But that, I would say, is a potential.
Hi, I'm Doug Brown from Falmouth. Just curious about that urine collection system. How is it pumped out by a truck? Is that a private contractor, or how does that go?
Yeah, in Sweden it works that way. In Germany it's run by the utility that's in the city of Hamburg, who are part of the demonstration. The point is that yes, it needs to be just organised like our solid waste are collected by roadside pickup. The storage tank at a household is typically designed so about 3 to 6 months storage time, and then it is pumped out. So this truck comes along and pumps it out, and then takes it typically out to the agricultural area, so it transports it, say, up to 50 miles away, and then it releases it into what's delightfully called a bladder. So it's basically just a large plastic bag that fills up as you fill it up with the yellow water, and it sits there by the agricultural site, and when the farmer wants to use it, he comes along or she comes along and plugs in basically a long hose connection into that, and then an instrument that's been designed in Sweden and is used in that part of the world that I'm familiar with, basically then injects it. So rather than having a heavy tractor and truck going up and down the field that causes compression, you just basically have this long hose going from the bladder, and you drill in under high pressure, squirt in the urine down about 3 or 4 inches, so you don't have the localization or loss of the nutrients, and it stays in there, and it just drills it in as it goes up the row crop, whatever you're going to be growing there. So it's done by a contractor to the farmer, and the farmer would be buying that as a fertilizer.
I'd just like to add that our septage haulers are licensed to move urine as well as septage. It's included. It's called liquid waste haul.
Or liquid gold.
Liquid gold.
What size storage tank is going to be appropriate? Should we have clusters of homes connected to the one and then collect from there versus individual homes? That's where we need to look at the physical layout of this community and think through that before saying what is perhaps the best option. But the first step is demonstration of urine diversion technologies, if you like, as in the toilet options, to get community understanding and what are the reliability issues associated with those sorts of toilets. Yeah.
As a sort of summer resident, part-time resident, I'm interested in how these composting toilets work under part-time usage. Do you have to have a house lived in 100% of the time, or can you do it on a 3 months off and 3 months on kind of thing?